Hello everyone. In this video, we're going to talk about question 7 on the 2014 Special Exam 1. This question was not very well done in that year, and it tests on differentiation and integration. So if you find chapter 6, 7, and 8 of the Year 12 Special textbook quite difficult, you can practice on this question. So there's a function fx being 3x times arctan 2x, and part A says write down the range of f. You don't usually get asked to write down range of a function that is a product of two other functions. So a good way to approach this type of questions, if you haven't seen it, it's probably to draw a graph, help you visualize what's going on. So let's say this is 3x, and I hope you're familiar with how to draw arctan. There's an asymptote here, there's an asymptote here. So let's think about what's going on when x is greater than 0. It's two positive numbers multiplied together, and it starts from 0, increasing. And then while the arctan would approach to a asymptote, but the straight line, the 3x, goes to infinity. So the product of these two still go to infinity. On the left-hand side, it's essentially the same shape, and this is two negative numbers multiplied together, so it's still positive, and essentially it's symmetrical about the y-axis. The answer to this question would simply be 0 to infinity. Part B, it's more standard. We just need to find out the derivative of fx using product rule. So it would be the derivative of 3x times arctan 2x plus the derivative of arctan 2x times 3x. And after a step of simplification, you would arrive at this answer. The harder part is probably part C. Hence, evaluate the area enclosed by the graph of gx being arctan 2x, the x-axis, and the line, these two straight lines. The keyword here is probably hence. We need to use what was done before to help us complete this question. And we need to find area, which is integration. So we basically need to find a half to root 3 over 2, integrating over arctan 2x. And I hope you know that there's no direct formula for this integration. If you read the formula sheet, you can't find anti-differentiation of arctan, but we can use what was calculated before. We know that the derivative of this function is this plus that, and there's an arctan here. So we simply need to integrate both sides of this equality. What's the antiderivative of a derivative? It's simply the original function. This is the fundamental theorem of calculus, and we need to evaluate that from a half to root 3 over half, root 3 over 2. And then I'll leave this as that, and then plus from a half to the same bounds, root 3 over 2 of this fraction, 6x over 1 plus 4x squared. Now we need to find this value, which is in the middle here, and we also know what's fx evaluated at these two values, and what's left is simply the last part, the anti-differentiate of this one. Be careful here. Please do not take this as arctan, because the formula here is a over a squared plus x squared, but here it's 6x plus a constant plus something x squared. You can't use this formula here. We need to use something else. the correct way to do this is to substitute the denominator with a new variable, let's say u, let u be 1 plus 4x squared, and then use substitution to work out what's the integration of this one. Hope you've learned something from this video. Hope to see you again.